being very receptive and giving checkups.
Oh.
So
there's the real story, huh?
Yeah, they wanted to pull her in for a checkup.
We'll see. All right, so how do you graph y equals x plus 5 to the 4th power? How do you graph something like that? Well, basically what they're going to show you in this section, what is true. You guys already know how to graph like y equals x squared, huh? What does y equals squared look like? Just a U shape, huh? So it turns out if you do any even power, like 2, 4, 6, 8, any even power, it's going to basically look the same. It'll just go up faster, so maybe I should make it look a little different. It's just going to go up faster, but it's still just a U. It's just going to go up. It's just a more narrow U because it's going up quick. So that's going off the screen there. So anytime you have y, let me just redo it a little closer. Anytime you have y to an even power, y equals x to an even power, 2, 4, 6, 8, whatever, it's going to be a U shape. The higher the power, the faster it goes up. But it's basically a U shape. And the same thing goes for odd powers, right? You know what x to the 3rd looks like, right? What's x to the 3rd? It's the snake one, like that. Well, guess what? If you do any other odd power, like 5th or 7th or 9th, same thing. It's just going to go down faster and up faster, so it looks more narrow, you know what I mean? But it's just going down and up faster for odd powers, you know? So even powers are U-shapes, odd powers. That is if they don't have anything else, right? I hope I'm being clear on that. In other words, if you just have the thing and the power, right? If you have other terms, if you have like x to the 4th plus 3x to the, not 7th, but 3rd minus 2x squared plus 5x plus 4. No, who knows what that's going to look like. That'll do all kinds of weird things, up and down, you know. I'm saying if you just have the one term to a power, if it's an even power, it's a U-shape. If it's an odd power, it's a snake on that. All right, so with that in mind, we can now graph things. So looking at this then, so you go, even power, it's going to be a U-shape. And what is the plus 5 going to do?
Left 5.
Left 5, because it's in the parentheses, so it's an x effector. It's going to have a right-left effect, since it's in the parentheses, right? And x is always opposite, so it's going to actually go left. Plus, we think of as right, but it's left 5. So anyway, having said that, I wouldn't think any of that. I think it's easier just to make the table, like I was showing you before. It's going to be the same thing on the exam, the next exam 2. I'm going to say, hey, just make a table. And find the 2 points, right? Just like we did in the last exam. Find the center point and one other point. How do we always find the center point? Yeah, make x's little world here 0. Plug in whatever it takes to make that 0. What could you plug in for x here to make that 0? Negative 5. So that's it. And when you plug that in, you're going to get 0. Negative 5 plus 5 to the 4th. That's funny looking. That's going to be 0. So that's 0. Okay, and then what do you do to find your 1? So that first off, that's back 5. 1, 2, 3, 4, 5, up 0. Boom. There's the center, right? That's how you find the new center. And what do you do to find the one other point? What's that?
Add 1.
Add 1. Yeah, we just add 1. And so that'd be negative 4. So if you plug in negative 4, what are you going to get? Negative 4 plus 5 to the 4th. That's just 1 to the 4th, right? That's just 1. So that's just 1. Back 4, up 1 right here, right? So there we go. So here's the back 5, up 0 center point. Here's the back 4, up 1 other point. And then the graph's a U-shape, so it must be going like this. Is that good? So that's the way we graph things, right? We find the center point and one other point. All right. And then I'll run out of time for the hard ones at the end. I don't want to do that. So... all right, so y equals 7 halves x to the 4th. So let's go ahead. Let's do the xy table. We know x to the 4th is going to be U-shaped. Let's find the center point and one other point. That's a funny looking center. So, all right, so the center point. How do you find the center point? What am I going to plug in for x? Yeah, just 0, right? Put in 0. What's y going to be? 7 halves. Well, I'll do it over here. Y is 7 halves times 0 to the 4th. What's that? Just 0, huh? So just 0, 0 is the center. The center hasn't moved. All right, and then what do we do from there? We add 1, so plug in 1. 7 halves times 1 to the 4th. And that's what? 7 halves. Or you can use it. I would use a calculator. Get this. Was that off the screen? Yeah, it is. 3.5, right? Just divide in your calculator. 3.5. So that's over 1 up 1, 2, 3, 4. So 3.5 about halfway between 3 and 4. Does that make sense what I did there? So just find the two points. Again, find the center, whatever will zero out the x zone. In this case, just a 0. You get 0, 0 for the center, and then add 1, plug in 1, you get 3.5, so over 1 up 3.5. So there's our two dots, right? 0, 0, and this is over 1 up 3.5. Connect the dots. We got a U shape. It just made it go up faster, didn't it? That 7 halves in the front, that was just a stretch, a vertical Y, 3.5 times as fast going up, huh? Is all that was. We good? Easy for you? All right, so let's try that one. So y equals x minus 8 to the 5th plus 4. All right, let me let you guys do that rather than me just jumping in and doing everything. So give that a try. Find the center and one other point. So what do you plug in for x to find the center? 8. We all good? Because we're zeroing out x's world, right? So the parentheses, right, is x's little world. You're just plugging in what will make x's, not what makes the whole thing 0. Right? The whole thing, y won't be 0. But just x's little world will be 0. Hey, when anybody listen to the YouTubes? When I wander around, can you hear my voice okay? Or should I stay more?
You're far away, but you can hear you.
You
You can still hear?
Yeah, it lowers a little bit, but it's fine.
You can still hear?
Yeah, you can still
You sure? Because I had a student in the other class tell me that he can't hear anything when I wander away. He's a little older, though, like me.
It gets
So
quiet.
It gets quieter.
It's quiet?
I mean, it doesn't.
You can
It's
hear?
not.
I can wander a little bit. All right. So, right, is that good? Is that making sense? Then, so you plug in what will zero out the parentheses, x's little world, right? So you plug that in, you get y equals 8 minus 8 to the 5th plus 4. Whoops, that's funny looking. So that's 0 plus 4, that's 4. 8, 4 is the new center. We good there? Does that make sense? So that's going to be the new center. So let me locate that over. Oh, I'm going to go off the screen. I'm sure. So 1, 2, 3, 4, 5, 6, 7, 8 up 1, 2, 3, 4 over 8 up 4 over 8 up 4. So there's the new center over 8 up 4. Now, what do we do to find the one other point? Just add 1, huh? Add 1 to whatever your first x value was, whatever your center x value was. Add 1, plug that in. So what do we got? Y equals 9 minus 8 to the 5th plus 4. What is that? 1 to the 5th plus 4. So that's just 5. You good there? Over 9 up 5. So over 9 up 5. So it's just right there. All right, so now, what kind of, so we have our two dots. This is the center dot. Right, always know which one's the center, right? Because that's the middle. All right, and then what is the general look of x to the 5th power? It's going to be the snake. Odd powers is the snake, right? So it must be going like this, huh? We got it, right? Is this getting easier and easier, this graphing? Just get the general look of the graph. So we could pick the multiple choice easy there. Remember, it's not multiple choice on the test. All right, a little bit. Should be good practice. All right, so they're telling me the zeros. So they want me to come up with the equation. I'm working this one backwards. So they're telling me the zeros are -4, 0, and 2, and the degree is 2. So how do you do that? They want me to type in like the x cubed plus 3x plus, whatever, the equation from the zeros. Now, what are the zeros? Let's go to a graph. You don't have to graph, but I think it'll help us. Yeah, intercepts, right? Everybody good with that? Zeros are x-intercepts, aren't they? Remember we did that on our graphing calculator a couple times. The TI-84 calls them zeros, I think, right? And they're x-intercepts. So the zeros being, whoops, not 0. Well, yeah, one of them 0. The zeros being -4, 0, and 2. Those are x-intercepts. So that means back at -4 right here, and at 0, and at 2. Those are x-intercepts. Those are zeros. Okay, so, all right, so what? So that means the graph hits the axis at those places, right? Like, for example, maybe it's up here, comes down, goes here, goes there. I don't know exactly. We'll get to that in a minute. But it does something like that, right? It passes through the x-axis at those 3 locations and nowhere else, right? All right, so what does that mean? We don't have to draw the picture here. We're supposed to go on the equation. What does that mean about the equation? Like the -4, let's just start with one of them, the -4. Doesn't that mean you need x plus 4 in your equation? Why? Y must equal x plus 4, and then some other stuff also. But one of the pieces, multiplied pieces, factors is the technical math term for multiplied pieces. One of the factors must be parenthesis x plus 4. Why? How do you know? Because I already know that if I plug in -4, I get a y height of 0. It's a 0. So it's got to make somebody, you got to have a piece that's sticking -4 into it and makes that piece 0. Times whatever, 0 times anything, the whole thing is 0. Right? Does that make sense? And then what is the fact that another 0, that's -4, another one's just 0, that means x minus 0, or just x. Right, I can just say x. And then x with the 2 means x minus, notice it's always the opposite sign, huh? Right? The -4 made an x plus 4, because you got to make it 0, so it's opposite sign. And the positive 2, 0 made an x minus 2 factor, opposite sign, because again, you got to have something so that you plug in 2 to it, and it makes that piece 0. And then in the middle, we have just an x, or x minus 0 if you want. I mean, it's still just x.
It could be to the power too, no?
Good point. Good point. Let's talk about that, because you're right. So first off, everybody good with this whole thing before we get into the power talk? Is everybody good? You got to have those 3 pieces at the least. Right? Because we know that if you plug in 0, 2, or -4 for x, the y is going to be 0. Because they told us those are zeros. Yeah, now, how about the question, how do you know this isn't like a second power, or third power, or fourth power, or some powers? Because that would still be 0. Yeah, how do we know? It's a good question. It's on the screen. It's telling us, it's saying... Yeah. What does degree mean? Highest power. Yeah. So that means x to the 3rd. This is an x to the 3rd kind of thing. So in other words, you can't, it turns out these must all be first power. You don't have to show it, but just for added emphasis, I'll put the ones on there. They must be first power, because if I was to FOIL this out, the front term would be x to the 3rd, huh? Right? If I had 2 powers on anybody, then it would go to x to the 4th, wouldn't it? All right. Good. And then leading coefficient 1. Did you notice that? That means in the front there's just a 1 or nothing, same thing. There's not another number as a leading coefficient. Again, the idea is if you FOILed all this out, what would be the front term? Well, it would be x times x times x would be the most powerful term. You tracking with me on that? Everybody seen that? I don't want to bother to FOIL. We're going to have a bunch of these. They're going to have a bunch of parentheses. They're going to have powers. We do not want to bother to FOIL them out. But I want you to imagine FOIL them out, right? And because all we need is the front term. So if all you need is the front term when you FOIL things out, just take the most powerful term, most powerful term, most powerful term, right? X, 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 x cubed with the 1 in the front. 1x cubed. If I was to FOIL this out, it would be y equals 1x cubed plus blah, 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 I don't know. I don't know the rest of the details. That would take work. But I know the front term is positive 1x cubed because that's going to be the most powerful term. Good? So we can easily find the front term, which we're going to need to. So there we go. That's all they're going to want from us on that. And they'll let you, by the way, type it in just like that without foiling it out. I tested it in my other section. They'll let you. Is that good? Questions on that one? All right. They're gonna tell us some zeros and the multiplicity. Now again, the multiplicity means the power on that parenthesis factor. So go ahead and write what you can about that equation. So we have a minus 7, a 0 that is minus 7, and his multiplicity is 1. So the minus 7, that's going to be x plus 7 to the first power. Does that make sense so far? Opposite sign, right? So that if you put in a minus 7, it would make that one 0. It's a 0. And the multiplicity means the power. All right. Next one is a 0 of 1, multiplicity 2. So what do you do with that? X minus 1, second power. So that if you plugged in a positive 1, you'd get a 0. And the multiplicity is the power. And that's all they're giving us. And the degree is 3. And the leading coefficient is 1. So put a 1 in the front. We're done. Is that good? That'd be degree 3, wouldn't it, if you multiplied that out? Because this would be x squared. If you FOILed it, the front term would be x squared. That'd be times x, be x cubed. Third degree.
Do you have to put the 1 there?
No, the 1's not needed. Good on that? Questions? Christopher?
Just the results of the multiplication of the x's?
We can type in just this. Yeah, we don't even have to FOIL it. Yeah, they don't, not required. Good?
The degree is the power of both of them?
Yeah, well the degree is if you were to FOIL this out, you know, if I was to go x plus 7, x minus 1, and you know what I mean, and just boom and a boom and a boom. Let me just do one and make sure we're understanding. X squared minus x plus 1, then x plus 7. Then I was to, like, you know, clean this up. X squared minus 2x plus 1. I was going to go boom, boom, boom. I'd get x cubed, blah, 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 blah. X cubed would be the front one. Right? If I was to FOIL that all out. Yeah, that's the degree. That's the front term. So you don't need to do all that, right? All you need to do is take the biggest one, the biggest one, the biggest one, or the front. That's going to be the front, isn't it? All right. So, well, I say biggest because they could write it 7 plus x, right? And you should still use the x. So I mean, when I say the biggest, I mean the one that has the highest x on it, right? And they could give you 7 plus x squared, and then you'd want to use that one, the biggest power x. As you're thinking about, if I was to FOIL this out, what would be the biggest resulting term? Take the biggest in each parenthesis. That's going to be the biggest front term, right? The highest power term. All right, so, yeah, they're going to want us to go through all the deal. Let's start with list each real 0 and its multiplicity. So can you do that? Can you take that expression? Now we're going the other way, right? Instead of giving us the zeros and asking us to come up with the equation, they're giving us the equation and asking us to come up with the zeros. So can you do it this way? Can you take that equation and find out what would make it 0? So really, you can just set the thing equal to 0, huh? And solve it. All right, just see if you can figure out what would make that thing 0. Let me give you a second. I think you'll get more out of it than if I just do it. Go ahead, give that a try. So what do you think? What's going to make that thing 0? First off, what is the minus 5? That doesn't even have an x, so he has nothing to do with making anybody 0, huh? Does that make sense? It's only the parts that have x's, first off, that have variables, that can have any number to plug in and make it 0. We good so far? Right? So that's ignore leading coefficients. It doesn't matter. Now let's take the x squared plus 4 and say, all right, I'll just take it separately. How can x squared plus 4, what could I plug in for him that would b squared add 4 and be 0? Correct. Nothing. Nothing. Nothing at all. Think about it with me. Let me give it to you from two views. Let me just reason with you logically, and then caution you about an algebra mistake that I see a lot of people make. First off, isn't it just true logically? Imagine plugging any number in there. Positive number, negative number, whatever. It's squared. So it's going to become positive. Or 0 at the lowest if you plug in 0. Plug in anything negative or positive, it's going to be squared and then be positive. Then you're going to add 4. It's not going to be 0. It's going to be 4 or more, isn't it? Right? Because the first part is 0 or positive. Plug in 0 at 0. If you plug in anything else, it's going to be positive. And add 4, it's going to be more than 4. It's not going to be 0. There's no way. There's no way that piece of the puzzle is going to allow you to have any x values, any zeros, any x values that make the thing 0. That piece won't do it. The other piece will, but not that piece. Now, here's the algebra mistake. I see a lot of times, a lot of people will go like this. And so when they do that, then they think, well, negative 2. Right? That's negative 2 twice, so just negative 2. But that's wrong algebra. Do you all know that? If you're not sure about that now, become sure, because you don't want to go into calculus. That'll just kill you. If you're making those kind of mistakes in calculus, you're going to have a miserable experience, and bad things will probably happen. You want to refine your algebra skills. Do you know that's not true, right? Don't confuse x squared minus 4. That one works. Yeah, x squared minus 4, you can totally do it. It's x plus 2, x minus 2, huh? We call that a difference of squares. Difference, minus, subtraction, difference of squares. That's fine, but x squared plus 4, no. Right? Because if you think it's x plus 2, just try it out. We'll see it's not right. Because if you were to FOIL it, it doesn't. They're going to ask us if the graph will touch or pass through, bounce or pass through at that point. So let me show you what that means about the graph. So that means at over 5, 1, 2, 3, 4, 5, at over 5, that's the only 0, huh? That means that's the only place the graph of this thing is going to ever hit the x-axis. That's the only 0. That's the only x-intercept. Okay. So the question is the graph going to pass through that point like that? Or is maybe instead the graph is going to go boing and bounce? You can bounce at a point, right? How do you know if the graph is just going to touch it? Just touch it and bounce, or it's going to cross through it, pass through it? How do you know? What's that?
Degree.
Yeah. Do you know something about that? It is the degree. It's the multiplicity. It's the power on just that particular, not the overall degree of the whole thing, but just the power on that particular 0, which in this case is a third power. So we have x minus 5 to the third power. What is that power? Does anybody know what that power? That power tells you the story, whether it's going to bounce or pass through. If it's odd, which it is in this case, I got it backwards. It's not going to bounce. It's going to pass through. Am I on the screen? It's going to pass through. Odd powers pass through. Even powers bounce. Not bounces, bounce. Even powers bounce. Do we know that already? We know that already. What does y equals x squared do at his 0, the origin? Even power. What does he do? Does he pass through? He bounces. That's kind of a bad looking U-shape, but you know what I mean. He bounces, huh? And what does x cubed do? Odd power. At his 0, he passes through, doesn't he? Yeah, even powers bounce at their 0. Odd powers pass through. That's because an even power keeps everything positive, right? If it was positive before, it's got to be back to positive again. Whereas odd changes from positive to negative, huh? So that's why. Yeah, so just look at the power, the multiplicity they call it, and you'll know whether it bounces or passes through. Okay, so let's get back. So there, when they ask the question, which does it do, we'll answer. All right. So maximum. So we've got the passing through bounce thing. So now maximum number of turning points on the graph. The max number of turning points equals the degree of f minus 1 on the screen. Yeah. So the degree, or highest power. Well, yeah. The degree means the, well, I don't know how to say it really clearly. The degree means if multiplied out, completely, no, there's not another E in completely, huh? Completely out highest power term. Yeah. So that's what degree means, right? The highest, if you multiply the whole thing out, what would be the highest power term? That's the degree. If you take one away from that, that's the maximum number of turning points. Maximum. It doesn't have to have that many. So for example, if you have y equals, 7x to the third plus 2x squared minus 10x plus 17 or whatever, you would just look right there. That's all multiplied out, right? No parentheses. All multiplied out. Say, okay, there's the degree is 3. That's the highest power term. Degree is 3. So that means max turning points is 2. In other words, the function might go up and down and back up. So there's a turning point and a turning point. It's a TP, turning point. So a turning point is like if you're riding on a roller coaster, it's where you're going up, you're at the tip top and then down, and then you're at the very bottom and then back up, where you change from rising to falling or falling to rising. That's a turning point, right? From going down to going up, or from going up to going down. Those are turning points. And an x cubed graph, whatever the degree, take 1 away, maximum number of turning points is 2. Now it says max, meaning it can have less. You can have an x cubed graph that only has like 1 turning point, like an upside down. That could be an x cubed graph. There are x cubed graphs that only have 1 turning point like that. There are x cubed graphs that have no turning points at all, 0 turning points. You know one very well. What's that? I'm off the screen. I'm off the screen. What does y equals x cubed look like? That's no turning points. The snake? There's no turning points in the snake. Right? It's going up all the way. If you're riding a roller coaster, going up. Up, 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 right at the top, right at the top, up, 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 we're going up to more, up, 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 up. You never go down. There's no turning points. You never start going down. Right? That's x to the third with no turning points, huh? So when we say it's maximum 2 turning points, it might have less. It often does. It won't have more than 2, though. That's the most it can have. So that's valuable information. So we're trying to give you good diagnostic information, the ability to look at a function and know quite a bit about it. You'll be surprised how quickly we can get a rough graph, but graph that tells us a lot about the function without even plugging in any points or using any kind of calculator. Just by looking at the equation in a minute, we'll put it together. Well, we'll finish this one with one more question. Is that good, though? Is that turning point thing making sense? Then part D, and then we'll put it all together. Part D says determine the end behavior. So let me go to a new screen. And we'll talk about end behavior. So determine the end behavior. That means, what does this function do way over there? I mean, eventually, does it go up, up, up and away, or down, down, down? I mean, what does it do way off to the right? What happens way off to the right? Does it rise, or does it fall? Right? Is it going up, up, or down, down? How do you know? Well, what will determine that end? It's called end behavior. In the end, off to the right, because that's the end, what will it do? That is always determined by what? Most powerful term. The most powerful term will tell the story. Right? Because think about it with me for a minute, guys. If you have something like, well, let me not make one up. Let me do our actual one. So that'll be a good example. Minus 5, x squared plus 4, x minus 5 to the third. So there's our actual function. That's a That's a 2 power there on that one. Okay. If I was to FOIL that out, can you tell me what the most powerful term would be? Can you tell me exactly what it is? Everything about the whole entire, not just the power. It'd be minus 5x to the 5th. Plus or minus, I don't know, blah, 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 whatever else. Does everybody see that? I know with confidence that would be the most powerful term. How do I know? Well, I just take the front times the front times the front to the powers, right? If I was to write this out, this would be minus 5 times x squared, right? Maybe it'd help you if I did a step or two of the FOIL, because I want you to see that all you got to do is take the most powerful term in each piece, right? If I was to FOIL this out, what would happen? I go boom, boom, minus 5x squared minus 20, right? And what is this? This is x minus 5, x minus 5, x minus 5, right? Cube. Means if you were to FOIL all that out, right? I'm going to do about one more step and then say, see? Right? What would happen is you would have this times this, and it would be x squared. It would be minus 10x plus 25 times x minus 5. And then this times this. This would end up being x cubed. And that would end up multiplying this guy. You see how it would be minus 5x to the 5th in the end? So that would be the most powerful term if you were to FOIL things out. So you don't have to do all this. All you got to do is just grab the most powerful, most powerful, most powerful. To his power, though. To the power he's under. Right? So minus 5x squared and x cubed is minus 5x to the 5th. So that is the most powerful term. Okay, so what? Well, that tells us it's negative. It's negative. So think with me logically. This means it's minus 5x to the 5th. And I don't know what the other terms are, but even suppose they're positive, it won't matter. The minus is going to win eventually. Even if it's plus 100, x to the 4th, plus 1,000, x to the 3rd, plus 10 million, x squared, whatever. You know, I'm going kind of crazy. X squared, whatever. I don't care what they are. If the leading term is going to win eventually, right? He's going to win eventually. Eventually meaning if you go far enough on the x-axis to the right. If you plug in, if you're making a table, and you plug in 10, yeah, maybe it won't win. But you plug in 1,000, he's already going to win, right? 1,000 to the 5th power? That's 1,000 times 1,000 times 1,000 times 1,000 times 1,000. And then multiply by negative 5? That's going to overwhelm whatever x, because that's the 4th is only 1,000 to the 4th power. He's 1,000 times less. So whatever he does becomes chump change after a while, doesn't it? And we're only at 1,000. Try plugging in 100,000 or 1,000,000 or 1,000,000,000. So you see, end behavior will be determined by the most powerful term. Whatever he says will eventually go when you go far enough to the right. Does that make sense? So end behavior is negative. 5x to the 5th, it's negative. So this one's going down, isn't it? This graph is eventually, after enough time, headed down. Because the most powerful term, the end behavior, is negative 5x to the 5th. And that's what they want you to type in. Let me go to it. That one's all scribbled up. Let me go to a new screen here. They're going to say to you, on part D, let me give you the exact question. They'll say, determine the end behavior. They literally want you to type in minus 5x to the 5th. That's what they want you to type in, the most powerful term. That's literally the answer to part D. The end behavior is minus 5x to the 5th. Really, he's the determining piece of the end behavior. So, all right, so having done all that, can we do a quick rough graph now? Where does this thing hit 0? Positive 5? That's the only place it hits 0? What does it do off to the right of that? Down. Never to cross the x-axis again, right? It's going to go down. Now it might come up, and now we know it has a few turning points, but we know it'll never go above the x-axis again, or there'd be another x-intercept, and we know there's not any. We found that this is the only x-intercept. On the other side, well, wait, you tell me at the 5, is it going to bounce, or is it going to pass through? Is the graph going to go up here like this, or is it going to bounce down? Which one is it, and how do we know? The power, right? The power just on that 0. Third power, it's like x cubed. It passes through. I'll put a p for passes through. It doesn't bounce. Remember, if the power's even, it bounces. If it's odd, it passes through. So it's going to go like this. Now, I don't know that it won't like turn or something later. It might, because we already said there's a maximum of, what was it? 4 turning points, right? Because it's x to the 5th. It's always one lower than your highest power. So the max turning points is 4. It might turn 4 times, but it's not going to turn so much that it ever crosses the x-axis again on either side, right? So I'm not getting into those details. I don't know that much. I would really need a graphing calculator to answer those questions. But I do know the basics, that it's only going to cross the x-axis at 5, it's down below the x-axis after that, and above the x-axis to the left of that. That's a fair bit of information without any values plugged in or any calculator usage. Make sense? Questions on that? That all good? Question, Christopher?
Is that 5 because it says that that's X? Is that 5?
The graph, this is just asking if it passes through or touches there. It's just wanting you to say it passes through. Crosses is the word they use on that. All right. Let's do picture worth 1,000 words. True statement seems like. So let's just try it real quick. Can you just look at that thing? Find the zeros, find their multiplicity, do a quick rough graph, find the end behavior, put the dots. See what you can do on that one. X minus 6 to the 3rd, x plus 9 to the 2nd. All right, so what are the zeros? 6 and negative 9, they're opposite of, right? You could plug in 6 and that make that 0. You could plug in negative 9, it would make that piece 0, huh? What are the multiplicities? On the 6, what power is on the 6? 3, and the power on the 9 is 2. So that's odd, that's even. So what does that mean? Odd powers pass through, even powers bounce, like that. So if we go to the graph, we go over to positive 6, it's going to hit there. Back to minus 9, going to hit there. Right? What's let's do the end behavior. What's it going to do way off to the right? So it's going to go up, or is it going to go down? Yeah. So the end behavior. Let me write it over here. What's the end behavior? Meaning, if you were to FOIL this whole thing out, what would be the most powerful term? It would be just plain old x to the, 5th? Yeah. It would be positive, in other words, right? The end behavior is just regular old x. There's no coefficients in the front. If you just multiply that out, it would be x to the 5th. It would be positive. So end behavior is going up, huh? Not like a line, but, up somehow. Right, up somehow, maybe like that, who knows. Good to there? What's it going to do at the 6? It's going to pass through. What's it going to do at the negative 9? It's going to bounce, huh? So it's going to pass through here, bounce there. Like that. Does that make sense on that? See how quickly we can get a general feel for what this function's going to do? Off to the right, it's going up, up, up. Off to the left, it's going down, down, down. Has some kind of min or max in between. Only hits 0 at these places. Bounces there, passes through at 6. We know all that really quickly. What's the max turning points?
4.
Yeah, 4, because it's 5 minus 1. It's the power there minus 1. So at most, it turns 4 times. Right? I didn't show those. I don't know exactly where those are. I just know it doesn't have any more than 4. So really, in real life, what you would do is you would graph this. You would use this knowledge and technology as kind of a combo, And why can't you just do technology? Well, remember, technology is not smart. It's just fast, and so you would tell it to graph, but where do you you've already experienced it with tech. That's part of what I want in this class, what I think is helpful for you if you're going to go into engineering or something real with math and science, is to see how technology and regular knowledge fit together. You do have to have some knowledge of these things to use technology effectively. For example, if you knew nothing about this at all and you just told a graphing calculator to graph the thing for you, how would you know how big to make your window? How do you know if you have all the turning points? How do you know if you have all the interesting story? Do you make it this wide or that wide? You think, well, I did it, and then it's just going up after that. How do you know it's just going up? How do you know it's not coming down again? What if I just graphed it and I just saw this? You know, how do you know it's well? How about if you saw? Let me give you some for instances about what I'm talking about. What if you graphed on your graphing calculator and you saw it go up and then down and then back up and then over here? Yeah. What if you just saw that? Would you wonder if over here maybe it goes down and back up again? And so maybe you need to graph more over there. How far? Negative 100, negative 1,000, negative 10 million? Right? Technology can keep going. How far? Tell me why we know it doesn't do that. Why do I know if I saw this much in a window, I know the rest of the way it's going down. It's not even turning up again. How do I know? I'm not talking, so keep in your mind the difference between hitting the x-axis and a turning point, right? This is a turning point, and it didn't hit the x-axis. This is a turning point, and it didn't hit the x-axis. How many turning points do I have on the screen right now? 4. TP, that's a turning point. TP, went from down to up. TP, turning point, and this is a turning point, isn't it? I have 4. What's the max? There ain't no more. See how knowledge and technology fit together, because technology is just fast. It doesn't know about graphs. They're just, all computers do is plug in numbers super fast. That's all they do. That's all they do. They don't know nothing about nothing. Artificial intelligence is just that. It's artificial. I think it's very interesting. I studied it when I was a kiddo back in the day. I think it's very neat, some of the stuff they can do. But in the end, it is artificial, right? It's just numbers moving fast. That's all computers are. So you have to have real knowledge to tell it where to look and do numbers real fast, right? And you know that over here it's not doing anything more if you already saw those turning points, right? Make sense? Questions on that one?
Yeah, how do you know that last one did, that last turning point?
Oh, I don't. I said if I graphed in a window.
Oh.
Yeah, you think, how do you come up with that? Yeah, no, there's no way I could know. Yeah, so I need technology to some levels, right? Yeah, I was saying if I graphed in a window until the point where I found these, then I would go, oh, I got them all now. Because I have my knowledge and technology working together. Yeah, good question. No, I couldn't know without some help from technology on that. We need them both, right? We need them both.
Is this the only section that's due, or are you doing another section?
Yeah, well, it's 2 parts to it, though. This is part 1, notice. Part 2 is also due. 4.1, part 1 and 2 are both due. But just these, yeah. So, okay, let's try that. Let's try the same thing with that one real quick. So, same old kind of thing. Draw a graph, find the zeros, find out whether they pass through or bounce, find the end behavior. Just get a quick, rough look at the graph. So if you can do the same thing. That's what all those parts are going to ask you to do. Are we finding the zeros? So what are the zeros? So to find the zeros, just set the thing equal to 0, because we're trying to find, what makes y 0, and then solve. Right? What is the minus 7? Just the minus 7 have to do with zeros? Nothing at all. right? So don't worry about that. But the x squared does, huh? You with me? Anything that has an x in it. So you could do the whole minus 7x squared if you want, or just x squared. It makes no difference, right? Any piece of the puzzle that can become 0 will make the whole thing 0, right? So basically you have to solve two equations. You have to solve x squared minus 5 equals 0, and you have to solve minus 7x squared equals 0. Does that make sense? Right? Because they're multiplied together, right? It's minus 7x squared times x squared minus 5. So if either one of those becomes 0, when they're times, the whole thing will be 0, right? The whole y will be 0. So basically, when trying to find the zeros, set each factor, each multiplied piece, equal to 0. All right, so how do I solve minus 7x squared equal to 0?
0.
Yeah, can you just look at it? I'm with you. Can you just look and go, I don't need to do anything formal. Only if x is 0. Now, if you want to be formal, that's okay too. You know, but I would just, yeah. You could, you know, if I wanted to be formal, I would divide by -7, but that's just 0. And then I would root it, plus or minus even, but that's all just 0, isn't it? It's just 0. The only way to make minus 7x squared 0 is to make x 0. It's the only way. So there's one of our zeros. That works. That's okay. That's a good one. And now how do we solve this one?
Square root of 5.
Yeah. Not just the square root of 5, though, right? What else? Plus or minus. Yeah, don't forget the plus or minus. So move that 5 over, becomes a plus 5, right, when it moves over. Okay. And then, remember, when you put a roof on the house... Did you guys like my dorky sayings? I try to make it so dorky. No, actually, I've tried to think of one that's not so dorky, but I can't. So I'm just stuck with it. So when you put a roof on your house, you've got to go up and down the ladder. Plus and minus. You've got to remember that. I make up goofy sayings when I teach something in grade tests, and tons of students forget something. So that happened years ago. And ever since then, I've gone with this goofy saying, and some things have improved a bit. So up and down the ladder.
Not the cell has a button for plus minus, right?
I think they do, yeah. So x is plus, so plus and minus root 5 and 0. Those are our zeros. There's 3 of them. 0, plus root 5, and minus root 5. Those are the 3 x values that will make y 0, huh? Is that good? Is that making sense on that? So go to the graph now. See if you can do something good with that.
So we're just going to want the positive one for that, right?
Just want the positive one for that?
But it was plus and minus?
No, we want them all. Yeah.
We want them both?
Yeah. So we want 0, we want plus root 5, and we want minus root 5. They're 3 places on the x-axis where that function's going to hit 0. Does that make sense?
When you type it in, do you actually have to put plus root 5?
I think so. I think that's what they want. I don't think they want a decimal, but they'll tell you. They'll tell you if they want a decimal, but I think they actually just want you to go 0, comma, root 5, comma, negative root 5.
Oh, okay.
Yeah, I'm pretty sure that's what they'll want. Good so far? Those are the 3 zeros. So don't forget that plus or minus. My roof is leaking. All this rain has got. Did I tell you that already? My roof is leaking, and it's like thousands of dollars, because I have solar equipment on my roof. And so I asked the roofer to go up there and look, and he went up there and said, your solar equipment's in the way. He said, call the solar company. So I called the solar company. They're like, sure, we'll move that panel. One panel, $500 to move the panel. Like, really? It's just one panel? Yeah, that's our price. Anyway, I won't tell you about all my problems, but hopefully you remember, when you've got a problem with your roof, up and down, so don't forget when you put a root on both sides, plus and minus, it'll mess you up if you're forgetting that. All right, so go from there now. So now figure out which of those points are bouncers and which of those are passers through, and look at the end behavior. I was telling my wife, $500. I'll just go up on the roof and see if you can disconnect those. My wife was, she knows my mechanical skills are not the best, and I would probably fall off and die as well. She's like, no, let's just pay the $500. Don't go on the roof. That'd be crazy. All right. So what's it going to do off to the right? Is it going to go up? Or is it going to go down? What's it going to do? What's the end behavior? Which means, remember how you do end behavior? It's the most powerful term. So if you were to FOIL this out, what would be the most powerful term? Minus 7x to the 4th. Good? That'd be the most powerful term. So it's going down, isn't it? It's going down to the right. Negative. Down. Okay, and now, how about the pass-through bounce thing? So what do you know about that? That's all about the power on the individual 0. So what's the power on the root 5? In other words, if you're to let me show you. If you factored it, I think I could help if I showed this. It's minus 7x squared, x plus root 5, x minus. You really have to factor it out. That's what it would look like factored out, huh? You with me? Am I making sense for you on that? I think I should have said that earlier. And so this is first power, this is first power, and this guy's second power, isn't it? This is the x equals 0. So he's a second power. And this is the other two, and they're both first powers, aren't they? So which means he's a pass-through, and he's a bouncer. Because he's even power. Everybody see that? Right? The x equals 0 has an even power, so that's a bouncer. And the other two are just first powers when it's all factored out. Right? Does that make sense? How that works? Right? You know, if I were you, I'd probably think, wait a minute, but it's x squared minus 5. Yeah, but there it's not factored, right? It's x plus root 5, x minus root 5, right? They're two individual different roots. You might say, well, yeah, but the x squared, well, that's x times x. That's the same thing twice. That is x squared. Whereas the plus root 5 and minus root 5 are two different things, aren't they? So there's only one of each of them. But there's two of the x equals 0. It's squared. Right? So it's even, it's a bouncer. The other two are pass-throughs. All right, so we got the story now, right? It's down here, kind of work our way from the back to the front, you know. It's going to pass through, bounce, pass through. I know that's generally what it's going to look like, right? What's the max turning points? 3, because it's, you know, the 4 minus 1, 3. So here's a turning point. Here's a turning point. I mean, I don't know exactly where those are, but there's going to be turning points. That's all of them, huh? I know there's no more because that's already 3, and that's the max. So, yeah, there's got to be a turning point between 0 and minus 5. So, for example, if this was some kind of science thing you were doing, or an economics thing, you know, you're trying to say, or, I don't know, some other kind of chemistry thing, and you're trying to find, where's the maximum rate of whatever in the chemical reaction? Well, you know there's only 2 places to look for a max. Here and here, somewhere. It's got to max between those two. Why? Because you know these are zeros, right? And it's got to hit these two, so it's got to have a max in between, and no other place, because there's no other turning points. You would know, so that's how your knowledge would work with technology. Then you would tell the little calculator or the computer or whatever to search for a maximum in there to find the max. See how that works? You would know that much information with confidence and tell the technology to do its thing under your direction. Good? Does that make sense? And in fact, I think they will, they will. Let's do that, guys. You guys have your graphing calculator? They will, actually. I don't remember which question it is, to tell you the truth, but just, I don't want to go through all the parts and find out. On some of these questions, they will ask you to find those little maxes and mins and things, because what they're going to ask you is, where is this function increasing and where is it decreasing? Well, actually, you know what? I know it's not this one because it's not there. So let's hold on. I do know. I'm just looking at A, B, C, D now. It doesn't say it, does it? So let's go on. It's one of the other ones. We'll go on to one of the other ones that does say. Any questions on this one before I move on then? So we answered all their questions. Stories about roofs and things. All right. So let's see. All right. So I know you can't see the graph. I'm going to draw it for you so you can see it better. It basically goes like this, like this. Oops, that wasn't very well done. This. Like a low here, a high here. It hits here, it hit here, it hit here. This one's at, what, -4, it looks like. This one's at -2. This one is at, what's that, 3? 3, okay. There's what we got. It's off your screen. So there's what the graph looks like. So it says, all right, the real zeros. What are the real zeros? That's just the -4, -2, 3, huh? Right? The real zeros. And then it says the least degree. What's the lowest degree? In other words, could it be x squared?
No.
If it was x squared, if it was y equals x squared, blah, blah, blah. If x squared was the most powerful term. That couldn't be, could it? Because if it's x squared, it would only have, what's the max turning points?
1.
You can only have one turning point. This thing clearly has a turning point here, right? TP and TP, turning point, turning point. It's got 2 turning points. So it's got to be x cubed or bigger. It could be x to the 4th, because that's got at most 3, but could have less. The third power has at most 2 turning points. So it's got to be x cubed or bigger. So when they say what's the least degree it could be, x cubed. That's the lowest degree that thing could be. It could be more, but that's the lowest
Do
it
you
could be.
type x cubed or just 3?
I don't know. 3. I think 3 would be my guess. But try them both if that doesn't work. Good on that? That easy enough? I can't write on that screen. I thought my pencil keeps giving away, so I keep thinking, oh, there goes my pencil. All right, yeah, pencil's still working. All right, A. So could it be A? Well, how about the knowers? Tell me why no.
Because it doesn't look like
Negative.
what we were doing before.
Negative. Look at that negative in the front. That means it's got to go down. It ain't going down. No. Right? End behavior. There's several things to think about. That's one automatic disqualification, right? If you were to FOIL out A, the front term would be minus 4x cubed, wouldn't it? Wouldn't that be minus 4x cubed, right? Because minus 4x times x, minus 4x cubed. That's down. That's the end behavior going down. This one's going up. So it's not A. It's got to go up in the end behavior. So it's not A. Let's go on to B. Could it be B? Anybody have any problems with B? Yeah, I think B's good. I think B's definitely a candidate. We don't know for sure it's B, but it could be B. B's possible. There might be other ones too. We're not done. Could be, again, it could be multiple answers here. B is possible. Why? Well, look at x equals 2. That's a pass through. This one's a bounce, and this one's a bounce, huh? You with me? Just looking at the graph, right? What does that mean when you're a bounce? Even power, usually 2. So that means this one at 0, this one at 1, this one at 2. This has got to be x, This has got to be x minus 0, or just x, to an even power. This has got to be x minus 1 to an even power. This has got to be x minus 2 to an odd power, like 1 or 3 or something. Right? You can just make this x. But it's something like that, isn't it? X minus 0 is just x, right? That's the 0. But it's got to be, it's a bouncer there, 2 power. 1's a bouncer, 2 power. 2's a pass-through, like a 1 power or 3 power or something. Right? So, yeah. And also the leading, if you FOILed out B, the front term would be positive x to the whatever, fifth. Be positive, it's up. So B's hitting on all cylinders. B is certainly qualified. How about C? Well, what's the problem? Somebody give me a problem with C.
It only has 2 turning points.
Really? Yeah, that's true too. The turning point, I didn't even think about the turning point. It's good. Good point. Yeah, if you multiply that, that'd be 3x to the 4th.
To the third. It could have 2 turning points.
3x to the 3rd. Yeah. It's 3x to the 3rd. You can only have 2 turning points. We have 1. Oh, no, that's not a turning. Yeah, that is turning point. 2, that's a turning point right there. 3, 4. We have 4 turning points. You got to be 5th power or higher for us. Huh. We have 4 turning points. Good point. It's not C. No. Not A, not C. Also, the x minus 1 is supposed to be squared, isn't it? And so is the x. It's supposed to be even power. They're bouncers. They have them as odd power. So that's not possible. So C's out. How about D? Is D possible?
Yeah.
Give me a problem with D. X minus 2. Yeah, the x is not squared. Good. X is supposed to be squared. It's a bouncer. And x minus 2 is supposed to be odd power. It's a pass-through. No, D's out. Right? So there's different issues for different ones. How about E? No. X, how about x is supposed to be squared? There's other issues too. X is supposed to be squared. It's a bouncer. No. And how about F? X is supposed to be squared. Yeah. The negative is not a problem because they turned this one around. So that's the negative x times negative x is actually positive x squared. So that one would be, watch out, they're being tricky there. That one would be positive in the end. Do you see? The leading term, if you multiply the highest power term here times the highest power term here, negative times negative is positive times positive is positive. So that one's going up to the right. It's positive in behavior, but he doesn't have x squared. So he's no good for that. So it's only B on that one. Is that good? There's another one like that, but they're pretty much what we've been doing. They really are. I don't think it'll be too bad now that we've been through all this. It's almost nothing new. It's almost just the stuff we've been over. So, except they do want you to use your calculator. Let me show you. All right. So, analyze the polynomial function. So, x squared times x minus 10. So, it's going to be all the same kind of questions. Find the end behavior. Find the zeros. Does it pass through? What's the multiplicity? Does it pass through? Does it bounce? You know, how many turning points? All that kind of stuff. So, let's do all the same stuff. So, let you go ahead and go find the zeros. Start by finding the zeros and whether they're bouncers or passers through, and make a quick little graph. It's all the same kind of stuff. Let's see if you can get a quick little rough graph.
I'll just screenshot that one.
All right, what are the zeros?
0 and 10.
Good, 0 and 10, right? Basically, if you set that function, x squared times x minus 10 equal to 0 and solve, then you set each part equal to 0, don't you? And so that just means x is 0, x is 10. Beautiful. All right, what are the multiplicities? Notice what's the powers on them? 2 and 1, right? This is a 1 power, and that's on the individual ones.
Oh.
We'll get to the overall third power thing in a minute. So 2 and 1, right? The powers on those individual zeros are a 2 power and a 1 power, which means a 2 power is even, so it's a bouncer, right? And 1 power is odd, so that's going to pass through, right? And let's do the end behavior. What's the end behavior right now? If you were to FOIL the whole thing out, what would be the most powerful term? Yeah, it's pretty easy. You could actually multiply this one. X cubed minus 10x squared. Yeah, it's right there. So the end behavior is x cubed, and that's positive, right? It's positive. So that means, what do we have? We have 0 and 10, and it's going up, up, and away. Positive x cubed is the end behavior. And at the 10, it's a pass-through. At the 0, it's a bouncer, right? You with me? Going too quick?
When we type in the end behavior, do we have to put positive x?
No, nothing. Just you type x cubed. Yeah, it'll take it. Right, so it's going to pass through at the 10. Pass through. And it's got to come back up because it's got to get up to 0. It's got to bounce there and then never cross the x-axis again. So there's the rough graph. Isn't that good? How many turning points are we looking at? There's 2. What is the max turning points? It is 2, right? Because it's x cubed, take 1 away. 3 minus 1, 2, right? You just take that 3 there. So 2, and we've got them. Here's a turning point. Here's a turning point, huh? We good with that? Let me go to a new screen and do the same thing, basically, and some more. Okay, so again, we have the graph. 0, 10. This is a bouncer and a pass through. Like that. We good to there? So we have a couple turning points. This is a TP, a turning point, and this is a TP, a turning point. And that's all the turning points, huh? Because this graph max turning points is the degree minus 1, so it's 3 minus 1, it's 2. 2 turning points maximum. We've got them. 2 TPs. Boom, boom. Right? 2 turning points maximum. Now, now the new question, this is basically the new question, it's not much, is they're going to say, all right, tell me where the thing is increasing and where it's decreasing. And we're going to need a graphing calculator. So, how do we know where it's increasing? Think about the roller coaster. Okay, so they're going to ask, first off, where, one of these parts on down the line, they'll say, where is the thing increasing? Oh, hold on. They're going to ask you for the Y-intercept. Let me do that real quick. You guys know how to do that. How do you find a Y-intercept? Before I forget. Y-intercept. Good memory. You always set the opposite letter to 0. Do you remember that for intercepts, right? X-intercept make Y 0, Y-intercept make X 0. Right? We've been finding X-intercepts and setting the whole function Y equal to 0. That's what we've been doing a lot of, right? Now they're going to also say find the Y-intercept, so that means you make X 0. So if you take that function and you plug in X 0, boop, boop, you're going to get 0 times negative 10. You're going to get 0. So the Y-intercept is 0, 0, which we can see right on the graph, huh? 0, 0. So you know that. Just want to make sure you're okay with that. All right. So back to the increasing, decreasing thing. So where's the function increasing? Here's a common mistake I see students make. Sometimes students will go, okay, that's a decreasing part right there. That's not right. That's an increasing part. Why? What's wrong with what I just did? Yeah, you got to make sure you're going left to right. It's a small thing, but it'll mess you up. So make sure, remember, the roller coaster's going for, otherwise any piece could be going, any mountain, it's like saying, does that mountain go up or down? Well, depends which way you're going on the mountain. It goes up and down, right? So any piece of graph can go up or down, depends which way you're going. So we always mean left to right as you go to increasingly positive x values, right? Okay, so remember, the roller coaster is always going from left to right. So if you're on the roller coaster going from left to right, this is increasing, increasing, and then there you're at your max. So this is increasing, and then let me change the thing here. So then in here you're decreasing. The roller coaster is decreasing, right? All right, and then now it's increasing. Oh, in fact, that's all the way, all the rest of the way. It's all increasing. Right? So we have 2 increasing pieces and 1 decreasing piece. Agreed? So, all right, so they're going to ask you for where on the x-axis, if I let this x-axis go all the way, where on the x-axis exactly are your increasing sections? Well, it'll be from here to here, from negative infinity to 0 is increasing, right? So increasing is from negative infinity to 0, comma, and then there's another section. It's here, wherever that is, to regular infinity. It's something to regular infinity, isn't it?
Would it be a bracket next to 0?
No, they just want parentheses.
Okay.
Yeah, because it doesn't matter. You're not right on the 0 or right on. It's just the sections, what you're doing in the middle. So anyway, so where is this spot right here? This is where it changes. This is where the roller coaster changes from going down to going back up. Right? Right at that turning point, huh? How do we find that? Graphing calculator. Find the minimum value. So just graph that thing on your calculator. You know the window, right? All you have to get is 0 to 10, really, on your window. Just get 0 to 10, hit the graph. If you have trouble seeing things, remember, hit the table button. Remember how I found that one YouTube I sent to you? So if you graph, the x min should be 0, x max should be 10, or anything in that neighborhood. And then graph it, the y, and if you're not seeing anything, go to table, look at the y values that it's making with the table, and change your window, your y min, y max, to fit those y table values, right? So you get a picture on your screen, find the minimum value right there. Somebody got that for me? What is that point right here on the graphing calculator? 6.6? And comma, and in fact, I don't even care really, huh? Whatever the y value is, all I need is the 6.6 x value. I don't know how many decimal places, whatever they ask for, you know. Anybody else getting that answer? Do I have a verification too? Yeah, good. Is that making sense, guys? So just graph that. Remember how to find minimums. If you have trouble, grab me after class. Be glad to help you. Finding minimums and maximums like we did before. So you see how finding that minimum helps us determine where it's. Oh, and I got it decreasing now. So it'll be the same answer. Let's answer, well, using the same point. Let's answer, where's the function decreasing? It's in this section here, huh? From 0 to 6.6, to whatever that point is we found. Right? This is 6.6 on the x-axis. Right? So the roller coaster from 0 to 6.6 is decreasing, isn't it? Decreasing from 0 to 6.6. Is that good? And then the rest of the questions is all stuff we've done before. That's really the only new part of that one. So I'm going to leave it. We got to do some factoring. I want to make sure I show you that trickiness. If If you're okay with that, questions on this one? All right. Okay, so number 6 here. Let's look at this one. So they're giving me a function, and look, they've got it all multiplied out, huh? They're not, it's not factored. There's no parentheses, right? It's all multiplied out. And we really need to see the parentheses to do what we're trying to do. You know, in other words, if I just asked you right now, guys, I just said, hey, set it equal to 0 like we always do, you know, find the zeros. I mean, how are you going to solve that? You need to factor it. You basically need to factor it, right? So when they don't have it factored, when they don't have parentheses, we need to factor. All right. So let me review with you in these 15 minutes from factoring. So how do you factor something with 4 terms like that? Do you remember? Or something?
You can factor up.
Oh, I didn't even notice that. Good observation. I did it a worse way in the other class. Good observation. Yeah. Yeah, they all have a 3 and an x, don't they? Yeah, good. I was just going to jump right into the 2, 2, which I will do in a minute, right? First 2, last 2, they have stuff in common. That's generally what you need to do with a 4-termer is 2, 2. But it would be nice, it would be a little easier to first take out the 3x, yeah. That would leave x cubed plus 6x squared minus, so I'm just saying whatever works, right? 3x times x cubed would go back to 3x to the 4th. 3x times 6x squared would be 18x cubed. 3x times minus 4x would be minus 12x squared. And 3x times something I don't know. Thank you. Minus, right? Minus 24. I don't even need the x because the 3x has it. Good. Take out that 3x first off. Thank you for that observation. Got to keep going, though. We need more. Now we got to go inside those parentheses. In the 4 terms, we do have to do a 2, 2 deal. That's how you handle 4 terms. So you say, all right. First 2, last 2. So just leave the 3x out there, right? In fact, I'll put a bracket just to make it easier. Brackets are the same as parentheses, just to make something look different, easier on the eyes. So first 2, last 2. So what do these first 2 have in common? X squared. X plus 6. We good with that? Because if you were to multiply that, it would be x cubed plus 6x squared. It'd go back okay, right? How about the last 2? What do they both have? Negative 4. Guess what that's going to leave? Yeah, we're looking for a match. They always match. Minus 4x minus 24, right? Good to there. Remember all this kind of this pretty hard factoring, complex factoring. Okay, so that 3x just stays outside. Now what happens inside? This I notice is kind of a tricky step. It is. It's a tricky step. To help, let me ask you, what would happen, guys, if inside the brackets there was an x, oops, there wasn't that. There was an x squared w minus 4w. Yeah, you'd say, well, that's easy. They both got a w. Take it out. We'd have to do that x squared minus 4 is in a, x plus 2, x minus 2. But I just want to focus on the w. You would go, look, they both got a w. Take it out. Right, and that's, instead of both of them having a w, they both have a parentheses x plus 6. Same game. Same game. Put the parentheses x plus 6 in the front, just like you would put a w. And have another set of parentheses where you have the x squared minus 4, right? Because that x plus 6 could go boom and boom, and it'd be back, huh? See, that's the same thing. It's just, but it can throw off our eyes because it's got its own set of parentheses. It can kind of weird us out. But you see how it's the same thing as it would be if just a letter was in common, just a w or something? It's just, hey, they both got a parentheses x plus 6. Put it in the front. All right, good so far. We're almost factored on this thing. One more step. You know the x squared minus 4, right? We have to break that down. So that will be, whoops, I just erased that. Bring that, yeah, let me erase that actually. Bring it up here. So the 3x in the front, x plus 6. We have x squared minus, you don't need those brackets anymore. They were just kind of, you don't need them. They were just separating it for a while. Anyway, last step is the x plus 2. Is that on the screen? X minus 2. Yeah. So there it is. There it's factored. Right? What if that was x squared plus 4? I would just leave it, right? We good with that? Remember we dealt with that a minute ago? The double-double Added can't be done. XX, 2, 2, it's a double-double. Added, you couldn't do it. But since it was subtracted, yeah, that we can do. That's x plus 2, x minus 2. So there it is all factored. I'm going to go to a new screen if you got all that down, and we'll answer all the questions now from the factored version. That's why we did all that, so we could answer the questions. All right, let's go to the new screen. So what was it? It was 3x. Well, I already forgot. 3x. X plus 6. Okay. X plus 6. X plus 2. X minus 2. All right. So there's the function f or y or whatever you want to call it. Now we set it equal to 0 to find the zeros and all the rest, right? Let's do maybe 1 or 2 steps, and we'll go try another one. So, all right. So can you find the zeros real quick? Now that it's factored, it's not too bad, right? So the first one is 0. The second one is 0. And you know, if you want to skip this step and just say, look, I know it's going to be opposite sign, you're right. You're totally right. That's fine with me. I never care. So it's going to be divided by 3. It's going to be 0, negative 6, negative 2, positive 2, right? It's going to be opposite signs of everybody. Those are the zeros. We good? So we could put those on a graph and do all the rest. Can I just stop there with that one? All the rest is the same. You know, put it on the graph. All those have multiplicity 1, so they're all passers through, aren't they? Right? Find the end behavior. The end behavior is easy. That's automatically already there for us. They've already multiplied it out, huh? The end behavior is 3x to the 4th. It's going up to the right, isn't it? And so we could answer all the rest. Really easy. In fact, I just want to even do the graph real quick. So you'd have a minus 6, you'd have a minus 2, a 0, a plus 2. It's going up to the right because the end behavior is, the end is 3x to the 4th. That's positive, that's up. It's going to pass through, pass through, pass through, pass through. I missed. Pass through. It's passing through all of them, right? They're all passers through because all of them are first power, first power, first power, first power. They're all odd powers. So they're all passers through. No bouncers. No 2 powers. So there's the general graph. It's going to ask you to find the turning points and the roller coaster going up and going down. And use your graphing calculator from there. Questions on that? It's getting easy? All right, can you factor that thing? Y equals, right? Because it's not factored again, right? We always, when there's no parentheses, are you catching this? You've seen the 2 different forms, right? So if they give me the parentheses, already factored, great. I just start with that. But if they don't, no parentheses, you got to factor that. You got to factor that. So go ahead and factor that, do the parentheses and stuff. All right, so take out the x. But that's not all. What can you do with the 1 minus x squared? Yeah. That is a double-double. That's a 1 times 1 is 1, and x times x is x squared. It's a 1, 1, xx with a minus. If that was plus, I would stop, right? Plus double-double, you can't do it. But if it's minus double-double, definitely do it. 1 plus x, 1 minus x. Is that good? Can I just switch the order on that? Just make it x plus 1, x minus 1? Is that the same or not? This part's okay, but not this. Right? You cannot switch the order of subtraction, right? Think about numbers. 5 minus 3, is that the same as 3 minus 5? No, it's 2 versus negative 2. No, you cannot. You can switch the order of adding, but you cannot switch the order of subtraction. So it must stay just like it is. So there it is. There's it factored. So what are the zeros? 0, negative 1, positive 1. Put them on the graph. They're all passers through because they're all the first power, you know, and the rest is the same. Let's go try. All right, 4.2. It does say we're supposed to start 4.2 today, so let's do 6 minutes of 4.2. All right, it starts by asking for domain. We've done domain before. Let's see what you remember. Was that exam 1? Was that information in, information out? Is it flushed out as soon as the exam is over? I did a little bit of that in my college days.
Still thinking about it.
So see if you still remember domain. I could have put that on the test we just took. Find the domain of that function. So what do we do?
Set x is 20 greater than or equal to.
Not greater than. That's under a root, right? Not equal to 0, right?
Not equal.
Yeah, denominators cannot. Remember, you look for trouble spots, like no knives in the toaster, kind of thing, right? Remember, domain says what can you not plug in, right? No tinfoil in the microwave. No denominator being 0. And if we have roots, no inside of a root being negative, that's where we do greater than or equal to 0. Right, so we say denominator, you cannot be 0. We don't care about the numerator. You can do anything you want, numerator. So that means x cannot be negative 20, huh? So the domain is anything except negative 20. It says type an inequality. I wonder how you can type. Okay, so same kind of thing. Domain means denominator 4x squared minus 19x minus 5 not equal to 0. Well, I'm sure let's spend our last 3 minutes factoring that, which I know is hard. A lot of people come to me and they want help with factoring. I'm glad to help. Come to me. Roberto is here. And Roberto, your hours are up there, right? Yeah, there they are. There's Roberto's hours. You do need to learn how to factor. Let's see how much you know. Can you, that's the 2 parentheses kind, right? It's a hard kind for a lot of people. You need to be able to do that, especially as you're moving into calculus next semester. You got to be able to factor, and I know a lot of people struggle with it. Come see me. Come see Roberto. Half an hour with us, and you'll probably be good. Try that one. There's lots of methods. I don't care what method you use, whatever. I'm just going to show guess and check, but you can do whatever you want. So you're just trying to find 2 parentheses that would FOIL out and go back, right? However you do it. There's all kinds of methods. So the main thing, if you want to get better, if you got to get to where you're sure when you factor. If you think you've got it, FOIL it out. FOIL it out. Make sure it really goes back. Make sure. There's no reason to be uncertain. You can FOIL and know whether it's right or not. Right? Because factoring is just unmultiplying, isn't it? It's just saying what was it before it was multiplied. All right, so I write my way is guess and check. I write the word FOIL, which stands for first, outer, inner, last. You don't have to do it this way. First or front, or however you want to say, front times front to make 4x squared. What times what makes 4x squared? Well, it could be 2x 2x, or it could be 4x plain x. How do you know which one? You guess. And if that one doesn't work, you go back and try the other one. It's 4xx. I can tell because of the 4 times 5 is going to make 20 and 1 with the 19. So I've done so many zillions of these, I can see how it's going to play out. But if you haven't done zillions of these, then guess at 2x 2x. And you'll find out that doesn't work. 2x 2x, it's good so far. 2x 2x, right? Okay, so now you jump to the last. Whoops, you don't erase it. You jump to the last, and you say, okay, last times last to make negative. Don't worry about the negative. I do signs at the end. Too much to worry about right now. Just what number times what number makes 5? Well, 1 times 5. Or 5 times 1, whatever. The order on the back 2 matters. Doesn't matter when they're both 2's in the front, though. Right? So remember that? Front times front to make front. Last times last to make last. Well, how do you know if that's right? You got to check the middle, which is OI. Stands for outer, outer, inner, inner. Outer with outer, inner with inner. So 1 times 2x is 2x. 2x times 5 is 10x. Then they have to somehow together make minus 19x by adding or subtracting. They can't do it. 2 and 10 make 12 or 8, depending on whether you add them or subtract. They're not going to make minus 19. No way. So no signs. There's no way that works. So go back and fix your 2x, 2x. That must be the problem. Make it 4x, 1x. Try that now. Try the inner, inner, outer, outer. The 2 inner, 1x. The 2 outer, 20x. Can they make minus 19? Yeah. Sign in the middle goes on the bigger. Plus 1 minus 20 makes minus 19, huh? Where do these signs go? He always travels up. The bottom one goes to the back. There's the factorization. You can FOIL it if you're not sure. You'll see it's right. I basically have FOILed it with all this FOIL checking stuff. So now what's the answer to the question? You set each of these equal to 0 separately. This one's easy. This is just x is 5. This one is move it over. Negative 1 divided by 4. So boom and boom. Meaning those are things x cannot be. X cannot be negative 1/4 or 5. Because either one of those values will make the denominator 0 and choke the function, huh? So x can be anything except those 2 values. All right, we're out of time. This is not due just for one. parts 1 and 2 are both due on Thursday, as Math Excel says.